It's getting recorded, right?
Yeah.
Yeah, okay. So our first question is like valid perfect square. We are given a positive integer num and we need to write a function. Uh, we need to write a function which will return true if your num is a perfect square, else false. And we are not supposed to use any built-in library. So these are the examples. For 16 it's true, you'll have 4. For 14 you don't have any. And constraint is like 2 raised to 31 minus 1. Yeah, many. I mean, how do you approach?
Okay, so we just have to find if the number is a perfect square, right? We just have to verify.
Yeah, yeah.
But while doing so, we can use any of the built-in library functions.
Library, yeah.
Yeah. And the number can be any big number, okay, but within the
Yeah.
integer boundary.
Yeah, this one.
Yeah. So for me, actually, I was trying this one. So I thought maybe, take this number, okay, and so I would actually uh, start from any number, like a two number, okay, and uh, see if the square of two, okay, is less than this number, right? And then keep on dividing the number by the number, say, two. And when I'm dividing it, I find how many times I can divide this number by two. If it is in multiples of an even number, then I don't say anything. I just continue for the next number, which will be three in that case. Okay. So
Okay.
if it's not in multiple of an even number, so I just return false there itself. Or I increment to three. Okay. And when I increment to three, I do the same thing, but I go keep on incrementing till like the square of the number, the whatever the index I'm taking, is lesser than the number, right? So in that
Yeah.
case, I'm actually taking care of the square root, okay, and as well I'm iterating, but I'm actually iterating from two, three, four, five, like that. So it might be a lot of
So,
redundant steps, but I thought that was a very easy way to do. There might be more easier ways also doing that. So just wanted to
mm,
share my approach.
yeah. So even binary search has been used. Like you can.
Yeah. So people say like it is. I think it's in the solution also. They talk about the
Yeah.
binary search.
Mm,
But yeah, those are more optimized way of doing it. Absolutely.
yeah.
But I thought this was a very quick way of getting a solution, and get
Yeah.
going. Yeah. So,
Getting to
but
the yeah.
right. So binary search will surely be a good way of doing that. And yeah, so if you have something much better, yeah, I would say.
Has anyone implemented using binary search? I haven't.
Oh, yes, I did.
Yeah, yeah, you can share.
Share my screen. It's a straightforward binary search, so nothing.
You calculated the mid first, and then. Yeah. Mm.
As this is a perfect square, so just looking for the exact match.
Yeah. And if it is greater than, yeah, it's a straightforward binary search. Mm.
But you are incrementing or decrementing the midpoint by just one, right?
Yeah.
Yeah, and then it will. No, I'm just setting the high, low and high. Then it will get the. You will calculate the new mid.
Oh,
This is what we do in typical binary
Yep.
search, right?
right. Sorry, yeah. That makes sense.
Yeah, it's a straightforward. In some process like Newton's laws are used. I mean, I don't remember this law. So any other method apart from this system?
Yeah, this is a very good way. Yeah, and it's like log n, right? Log of n, maybe. Yeah, we can call that.
Uh, my question.
Yeah,
Hello. Yeah.
yeah.
Yeah. So I was asking. So I tried the same approach, but what it was, I didn't. If m star m is greater than num, then I put my high equal to mid only, not mid minus one. That's because I was trying a test case where the 4 is answered, but my high was 5. Then if I decrement my high to mid minus 1, which is 4, then I'm losing that case, right? Like 4 I cannot find that 4.
So not sure because in a binary search there are a couple of template you follow that. So I'll always follow that with left and high should be exactly up to that at that level, and that's why I use in my while loop I use less than equal to, and there is another template which use just
Oh,
less than. So you have to check
okay,
that.
okay. So your ending condition may be low equal to high there, which low
Yeah.
and high equal to 4, right? Okay, yeah,
Yes. So
yeah.
there are a couple of templates for binary search. So there was one article on Lead Code. If I'll find that, I'll share that for a binary search template, what people follow.
Please share that. That would be
Got
great.
Yeah.
it.
Yeah.
In some they convert it to Boolean variables, true, false, and depending on that they calculate.
Yeah.
Some,
So it's better to stick with one style. So in that case, you will
exactly.
not make that kind of edge cases mistake in binary search.
Configure.
No, I don't think so. You have to stick to one style because in some cases you explicitly have to use some different ways.
Well, so far I did not see. I don't recall any scenario where I was not able to solve with my style.
No,
Yeah, it's like if you have to find the ceiling and flooring, yeah, so there might be
um,
a different way of doing
problems
it.
like rotation mid we calculate
Yeah.
no. I mean array is rotated, you have to calculate weak points. So there I have seen that people are using this Boolean like converting true false the moment they hit the next false. I mean it's all like
Okay,
this also.
let's take that later, maybe on a different session. Yeah, but yeah,
Yeah,
please share
Yeah.
the.
yeah. I'll try to find it. I think definitely I do have that link somewhere, so I will share that in this lecture.
Thank you. Yeah, no
Oh,
problem.
yeah, thanks.
Hello, am I audible?
Yeah.
Yes, absolutely.
Yeah, so in the code which Darshan showed, uh, I think we can make one small optimization that instead of going till num, we can go till num by 2 only.
Yeah, definitely because after that if you square it will go beyond your array. Like
Yeah, so a square root of a number lies between
one to next.
lies till num by 2 only.
Hmm.
Yeah, so that thing only. It won't affect much because that would be log of num by 2, the complexity.
Theoretically it won't affect, but computationally, I mean practically less number of computation will be done.
Right, right.
Yeah. Okay, good. Thank you.
I did with a simple for loop. That would just check
Doesn't share.
if the remainder is 0 or not. Let me show you.
Just share it, I think.
Yeah. So basically I go until half of num equal to num by 2, I equal to num by 2. Until then I run the for loop and see if there is a remainder is 0 or not.
So yeah, here you're running
Yeah.
only up to the mid of number.
Yeah. But that's this is linear scan. So
Yeah, that is.
But you could have gone like instead of I less than or equal to num by 2, you could have said like I square, I might multiplied by I less than num, or less than or
yeah.
equal to num, right? So that would be slightly lesser,
No,
That is I
that's
less
it.
than root num. That time.
almost like a square root, yeah.
Yeah.
Yeah,
But
but
not
this
much of a
complex.
difference though, yeah, but that's
This
fine.
is like a bottom-up approach.
Yeah.
Yeah.
So here if I is 0, then
That will be expanding binary search.
Which one?
That if you multiply I into I,
yeah.
so that is actually expanding binary search. Every time you are actually jumping twice.
No, only the condition I'm saying, you know.
Oh, okay.
Yeah. Okay. This is a good one too.
Yeah.
Yeah. Thank you.
Yeah, we can move to next. Oh, this one is. So it's the largest one bordered square. We are given a 2D grid of zeros and ones. We need to return the number of elements in the largest square subgrid, which will have all the ones on its border. And if you found any zero on the border, just return. I mean, yeah. If such subgrid doesn't exist, you need to return 0. So this is like all the borders are surrounded by 1. So total number of elements will be 9. And here you'll have only 1. And elements will be either 0 or 1. That's just straightforward. So how to approach any query?
I think brute way would be like for all the ones, try to find the how many ones in row wise and column wise are there, and see if it can form a square.
Yeah, but
That would be NQ solution. But like you need to find min of like how much you can make in row wise and column wise, and for the same row and column, see if it can form a square.
So you count the number of ones for each and every row.
No, whenever you find a one, like I move on into a matrix. Whenever I find a one, I see how many ones are there on that row continuously, and how many ones are there on that column continuously. Whenever you hit 1 0 in either a row or column, then we start looking into that row and that column to form a square.
I thought that was a very optimum solution.
Yeah. I don't know why brute force.
Okay. You have something to share, Dilip?
No, just assumption, but it's brute force like n cube, right? Like I think Session solved it in better way.
Yeah, brute force. Yeah, that might be
Because
something.
see, if we try and if there is only if we don't work, then we do go back and see like one row and one column lesser than that and see if it can form ones, and same way we need to for like that. So that would be
So I think the brute force would be n to the power 4, the one you just said. Like if we have a row and we are looking for the maximum continuous sequence of 1, so we'll have to run 2 loops in that case,
yeah.
just
So
for
it
finding the sequence.
n cube, right?
So this would be n square, and once we are done with finding the maximum loop, we'll have to go back also.
So for each number, you okay? Yeah, it will be n.
It'll be 2n square, right?
Yeah. So for to find every one in the matrix, it will be n square, and then to find if it can form a square for in that row and column, that would be n square, n possible.
And elements you can find just by squaring the cells.
Yeah.
Yeah. So there was one approach actually in the discussion.
Yeah.
So it was like, you calculate what you say, you use an extra space. Yeah, it's extra is the real extra, like have one extra space for an horizontal, uh, what do you say, rows, and one for the vertical prefix sum or something like that, So every time you see there is a one in a column, you keep on incrementing only the column values. And if you see like in the row, if you see all the ones, you keep on incrementing them in the rows, and then at the end you try to start from the bottom rightmost position of both these arrays, which are the horizontal or vertical, which are the two-dimensional arrays, and then you find whatever is the minimum of them, and you try to find if you are able to find a vertical as well as a horizontal with the same number. And if it's not, then you keep on decrementing till you don't find it. So, but I think the way Dilip was explaining it is slightly similar to that, but it is using extra spaces. Yeah.
Yeah, kind of like, you want to share code?
Yeah, I can share.
Sure.
Well, before that, I'll just explain you what I meant by that and what I was saying. Maybe I'm not sure whether it is clear. I'll just go here. So if you have this example, right, 101. Oh, I'm sorry. Okay, 111 on the top, right? 101 and 111. So what I was saying is, you first create another one vertical array, which will be an additional array. So here actually I'm going to increment only the columns 1, 2, 3 here, like 1, 2, 3 for this one. And then in this case, it is 101. And in the second case, I'm going for 1, 2, 3. So then I have another array, which will be just for the rows. So I just call it a horizontal. And
can I pause you?
Yeah, sure.
I couldn't follow that. 1, 2, 3, 101. What were you doing there?
Okay, see, so this is our input array. Okay. So the input array is like 3 rows and 3 columns.
When you are hovering, we cannot see your cursor. So when you said this, we actually lost you there.
Okay, you see this input?
Yeah.
Okay. So actually I'm writing by hand, so I can't hold the cursor. Sorry about that. Okay. So, okay, I'll try, but then it messes up. So this is the input array. So if you see 1 over here, right? So the way you find the cumulative sum for columns, right? So you look for 1, and then if you find a second one here, right? So I just add that, the previous one over here.
Okay.
Right? Then I create a cumulative sum just for the columns. So at least you followed that in the vertical one, right?
101 I couldn't follow. 1, 2, 3 I could.
I'm sorry. Could you please repeat? I just lost.
Mid column is
one, which is 101.
yeah.
So yeah, 101 because there is no continuous, right? So therefore you cannot add.
Okay, only if
Okay.
it is continuous, then you are adding to
Right,
the
right.
last one.
Yeah,
Okay,
because that is what the prefix sum value is, right? We keep on adding if it is continuous.
got it.
So for horizontal also you repeat the same, but in this case it will be for the rows, right? So you have 1, 2, 3 here because you have all the like the first column here, right? So this first column is 1, 1, 1. So you have 1, 2, 3, and then the same thing will be for 101, the second row, and this will be for the third row, right? So now what you do is when you have these two arrays, you take the bottom right, the bottom rightmost position of both these arrays and find out which is the minimum value in this. Okay.
Yeah.
When you find this minimum value, then you go the same step, like it is 3 here, right? 1, 2, 3 steps, and you see if you find a similar value here, okay, for the vertical. And in the horizontal also, you go in the column, and then you see if 1, 2, 3 position, if you find the 3, then you can declare that this value is the optimum one, and then you can return 3 multiplied by 3, which will be the value for our output.
So seeing 3 at the corner says that you have seen all the ones on your border, like all the
Right.
border is.
Because
That
we
is
just want to find the perimeter of that. We don't want to find the complete whole what you say square with all ones, right?
Yeah.
So therefore, this is the way it was done. Yeah.
Okay, one question.
Yeah.
In the vertical array, you circled 2 3s, and in horizontal also you circled 2 3s.
Yeah.
The resulting 3 by 3, which 3 out of these 4 did you select?
Well, actually, we have to compare, I can give you another example to make it slightly clear because here this example is very small, just 3 by 3.
Correct.
So what we are doing is we just want to find if we have 2 rows with the same element, right? So therefore you find 1 row over here and 1 row over here with a distance of exactly 3, right?
I think the
You
screen
have
is
to
stuck.
find for the columns also, right? In the columns also you have to find, it's not the rows, we have to find for the columns also, then only it will make a perimeter of a square, correct? So for the columns you have to go to the vertical array and then you actually have to look for the same value with 3 steps, and when you get that, then you just have to have that value as 3. Okay, so because you have to get it from both the arrays, and now your answer will be 3, but when you are returning, he needs the complete square value. So therefore I'm actually multiplying by 3, squaring the number, actually what I get.
So minimum of the both maximums, and then you squaring it.
Right.
What is the intuition behind this approach? I am not clear.
Well, actually, I just went to the discussions. I got that because it was not, I thought it was a prefix sum. I tried to do it that way, but I found this was on the similar line. So I was able to quickly grasp that. And that is the reason.
Okay.
Okay. So I'll just share my code. So things might be slightly. Okay, so these are the two arrays, okay, the horizontal and the vertical one. And when I come to this, it's a, what do you say, n square. It's a 2 for loops, listed for loop. And just update that value over here if it is equal to j0 or I is just 1, or else it is going to be the previous value plus 1, okay, in both the vertical and horizontal. And then the last part, actually you come here again, you start from the bottom right? So this is the first value which I get from here. I take this value as the minimum value and find which is the minimum of that position from the horizontal vertical array, and then I have to do a while loop over here, and then I just keep on finding here if that position, I was just talking about, right? If I find threes in the vertical and the horizontal, so this is the actually condition. If I find, then I say, okay, this is my answer, or else I actually have to decrease the minimum value again to get the exact results, right? If I don't find, then I move on to the next coordinate, maybe lesser than that. And then actually whatever value I get, which is the min V, actually which is stored in answer ANS. So I just return the square of that number.
The intuition behind minimum is like, let's say vertical you are having all the 3 ones are there, but in horizontal only 2 ones are there. So you are supposed to take the common one, right?
Yeah, the minimum of that, right?
Minimum of that, because if you take maximum one, because the other one will not have, so 0 will come in the border. So you need to you are supposed to take the minimum one which is common in those two. That's why we take minimum value.
Yeah,
Right.
because it is a square. If it would have been a rectangle, then we could have taken both the values 2 and 3.
Yeah.
Okay. So this was actually simpler to follow because I found other ones which were slightly more complex. But only this, the downside of this one is we are using 2-dimensional 2 arrays. Space is slightly more.
Yeah.
So I think this is n to the power 4, right?
This one?
Not n to the power 4. Actually, you see there are 2 for loops.
Sorry, n cube, right?
No, it's not nested also. It is n square, rows column, and twice n square, I would say.
No, you are using a while loop also, right? On line 29.
So while loop actually goes through this one, right? The last values. And actually I'm jumping and I'm only looking for, because even in the worst case, it's not going to go through each and every cell. Because.
But still, while will take like.
Let's say answer is 0 and we get min B as the row length. So I think it will
If
iterate.
it is 0 or so, then corner cases we'll have to find out. When actually I'm doing this calculation itself, I can find, say, some count value saying, okay, if I don't find any 1, maybe I can optimize there.
No.
Some sort. But yeah, I'm not saying it's going to be, what do you say, like more than n square, sure. But I don't think so it's n4. But maybe closer to n cube maximum.
Yeah,
So
that's what I'm
to some
saying.
extent.
So I have a solution. I'm just piggybacking on Santosh's solution. I don't have the codex source code, but I can explain. And it's like a DP way of solving. You'll just do it one pass on the matrix, and you can solve it.
Okay.
So go ahead.
I'll just stop here.
He is also doing DP only, but the extras,
Like I said, I have not coded, so I don't have very many.
Darshan, can you show it on the whiteboard, maybe?
Yeah, I'm doing
whiteboard
that.
if you can.
Yeah.
Sure. Let me unshare my screen. How to answer it. Yep.
So the matrix was, I cannot. Oh, 1 second, I have to get my pen correctly. Okay.
Yeah.
So the matrix was like this, right? 1, 1, 1, and 1, 0, 1, 1, 1, 1.
I think screen is.
Yeah, I'm not able to see anything.
Yeah, we can't see the screen.
Black stuff.
You'll have to share some drawing board. It's there in that.
Yeah, that's what I'm doing here. I'm writing on the Zoom whiteboard.
You write a sketchpad, you can open directly. You can.
Maybe you unshare again.
Okay.
Do it. Yeah.
One second, let me do that.
Please, yeah.
Actually, there was a problem on main lead code. Maximal square we have to find. It's just a modification to that. This one. I mean, square of maximum ones we have to find in a matrix of zeros and ones.
But that was a perfect prefix sum one, right?
Yeah, exactly. Yeah, that's why a slight
That's
modification.
more easier, yeah.
That is, yeah, these are problems you have, and just you check for the
Yeah.
next one. Hmm.
So is it like a sketchpad.io?
Yeah,
Yeah.
Sketchpad. Yeah. Simply write Sketchpad. It will get it.
Mm.
Yeah,
But you see a drawing on share, when you do a share, right?
that's what I tried. So I tried to share
Whiteboard. There
Zoom.
is some whiteboard here.
Yeah, I tried to share Zoom whiteboard and it did not like it.
Try
Like you
it
could not
again.
see it.
You
Maybe
can
try
try
it again.
again.
Yeah.
Yeah, now
Yeah,
we can see.
let us see. Yeah.
You can see that. Okay.
Yeah.
But I think when I put my hand, it's drawing. So let's see, 111, 101, 111. So you said in the first scan you do like row scan and then column scan, right? So which one you would like to do? For example, let's do column scan. So we put 1, 2, 3 based on your logic, right? 101 and 1, 2, 3. So now let's do this is we scanned the columns. If we find it, we incremented that, right? And then we do, let's say, row. So what we do is instead of having two different metrics, instead of having two storage, we work on the same input matrix. So in the row scan, what we do is if we find a non-zero value, then we increment. Also, we increment max out of, so in the corner I'll have 1, but my neighbor is 1, so we are scanning row wise. So my neighbor is 1, so I increment it 2, and the next neighbor is 3. When I come to next row, I have 2, right? So what we do is this is 2 and 0 because these two are like nullified, but and then when I go to the next one, what I need to do, so when I'm scanning the second row, I'm incrementing this previous plus 1. If this is 0, I'm not doing anything. So here I'll have 4. Right? And then when I go to the next one, I have 2 plus 3. And then when I'm scanning this way, I also need to do plus 1. So I'll have, and then max of, so I take this and this, whatever is max I get, I add 1. So this would be my 4. And like so when I go here, this would be 5 and sorry. Five and so 3, 4, 5, and then this is 4. So this becomes 9. Okay, let me explain this again. I made a mistake. So this we are clear, right? The first row we are clear. Then here what we do is we had 2. So 2 plus 1 is 3. And we add this 5. But this was 0, so we don't do anything. So we keep it 0. So we add 0 plus 1 is 1. And then we have 3 plus 1 is 4. So 4 and 1, 5. Well, I'm making mistake. So 3 plus 1 is 4 and 0 is 0. So we have 4. and then 4 plus 1 is 5. And then here it should be, sorry, 3 plus 1,
So
4.
what are you trying to do in the sense? So I can just.
So basically you add 1 to this, and then whatever is maximum you fill here. So at the end step, it will be like, 4 plus 1, 5. Here also 4 plus 1, 5. That you, so then you take one of them and add to this, which is 9. You get 9. So once you get 9, then it is the answer.
Mm-hmm. So you're trying to add all the ones, but this might be okay. But what happens if you see the input array actually increases in size, and it's not always you have this parameter square at the end, or maybe somewhere in the middle, then things might be complex to implement.
So
I'm not saying that it won't be possible.
What happens is, like, whatever we get maximum on the diagonal, that would be the answer.
Okay, yeah, maybe.
Yeah.
It might be possible, but if you see implementing wise, it might be slightly tough.
Yeah, I got little confused on, but like, I think it is, if you have 4, 4, then 4 plus 1 is 5, and then you just add this 4.
Mm-hmm.
So you do 4 plus 1, and so instead of adding 2, we just add 1.
Mm-hmm.
So we add this 2 and add 1.
Yeah, I just found this DP solution in the discuss, so I can.
So here, if we go 2, 2, we add 4, and this should be 5, but it was 0, so we keep it 0. And then here's 0, 3. So this would be like 3 plus 1, 4, and here's 0. So we keep 4 here.
Okay. Yeah, maybe possible. Yeah, I think Ashwini has one solution, right?
Yeah, I can share the link, I think, because it shows the example also. I think what he did is the Shashank, maybe you can share or that link.
Sure.
Yeah.
Yeah, definitely. Copy it.
So what they did is the row wise is the left. If you see the left 3, 3, it is the same prefix sum for each cell row wise, right? And then the column wise, what they are saying is we store the number of ones immediately above. So for the up, we are going to use the left one, I think. Yeah, I'm also trying to understand this. But
Yeah.
So,
It's like they are accumulating the sum row wise, and first left to right, and then top to bottom.
Yeah, then it is same like what Santosh did, right?
Yeah, that's why I told Santosh did the same thing. Just is not using.
Yeah, then
DP.
why it is saying it's a DP? Is it a DP or not?
Yeah, they call it a DP. Yeah, all of
The
these
problem
are
is there. No?
When you use an extra spirit, like say DP.
3 is depending on previous what you have seen 1. So that is a sub problem. 1, 1 you have already seen an array of size 2. I mean, array of size 2 containing both 1, 1 and 2 that. Santosh did the same thing only.
But I think what Darshan was saying, it might be a very optimized way of doing it. Yeah, if we are able to do that, but that was a good thought.
Yeah, let me try doing it, and I can post it.
Please, yeah, that would be great.
Darshan also give one example to understand like how you are adding up, what is adding up, because sometimes looking at the code it's difficult.
Absolutely,
to
it's very difficult to follow.
For the DP at least,
Yes, because now we are going to have the fun part in the last one solution.
Yeah.
Yeah, the last problem. Sorry.
Did someone try this recursively?
Pardon?
Did someone try to solve this using recursion or something?
No, if you have something, please share it.
Yeah.
No, I used the one which you have showed.
Okay.
Yeah, no, I think recursion.
Shashank has a different approach, right? Yeah.
I shared the same. Let me change the screen. It's visible screen, right?
Yeah.
Yeah.
Yeah, this is the DP one. Like, I mean, it's exactly same thing. The name is not giving. Otherwise, whatever you just said. So what we are doing first, we are creating a deep 2D array of size extra one. Why extra one this time doing? Let's say if we are at the first 0th element, so you will look for the left light, but left you'll go out of the bound, right? So it's kind of padding we are doing on the border area with 0, 0.
Okay.
Yeah, so you got my point, right?
Yeah. Yeah.
So
Yeah,
basically, I
Shashi,
don't
can you
need
give
that.
the example like there? So how your
Yeah, sure.
DP matrix will look like?
Let me open. Yeah. Yeah. So what I'm saying, how your DP will look like, this extra padding we are doing here, 0, 0, 0. If it is a 3 × 3, 0, 0, 0, 0, 0, and this is again 0. Let's say if your array is like the one example, 1, 1, 1, 1, 1, 1, 1, and this is 0. So when you are here, you look for your previous element, whether it was 1 or not. Because if it is 1, then only you are supposed to add this one, right? That is what here prefix sum we are doing now.
Right. Yeah.
Yeah.
So when you are this position, if let's say if I have not padded this, then I'll go like beyond my metric, below my metric, you can say, which will be out of, you'll go out of your array. So
Yeah.
that's why I'm doing this padding here. So that's why n+1 cross n+1 matrix I'm taking. And just observing if my previous element is 1, then to the next element, that is 1, that I'll accumulate the sum to 2 again. So initially it will be 1, then again if I see a 1, it will be 2, then 3, and again from top to down I'll go 1, 2, 3, and so this is first time I have seen. Next time I'll do like this, and then I'll take the minimum of those two, whatever value I get here, and depending on that I'll take the square of it. It's exactly what here Santosh has said. And minimum, I told you, just the reason behind taking the minimum is like, let's say if you have one row is containing 101, the other is containing all the three, right? So from this side you will have what, 2 you will get, let's say, and from set 3 you will get. So you'll have to take the one which is having all the common ones. Both are having
Right.
2 ones, and that one, the other one is also having 2 ones. So this is the logic for that. Sorry.
Okay.
I don't think we need to pad this because we can simply check if I-1 is greater than or equal to 0. If that is
That
true, then we can take the
it's the
previous
same thing.
element, otherwise just take it as it is.
Yeah, it's the same thing. You are checking the boundary
Yeah,
conditions by that. Yeah.
correct,
But
correct.
but then so in the Santosh solution he did the row wise, so the first row, then last row, all the rows, and then the columns.
Yeah, he
So here,
explicitly made two matrix, horizontal
yeah,
matrix and vertical matrix. Yeah.
right here, how are you combining both of these matrices here?
Yeah, that both I'm doing. I'll tell you in the code. Wait. Mm. I'm going through each of, each cell of the matrix from one to this. Okay. Now previous cell, that is, whatever previous cell, if that is your one, then I'm just whatever state this 0 means what, I'm going through the uh, row wise, like from left to right, and this 1 means I'm going from top to bottom.
Oh, so you took a 3D array
3D
basically.
array,
One
3D
is
recursion.
the for the row and the second is
Other is
for the
for column,
column.
and just I'm
Okay.
appending one.
Okay.
So if you
So
could
you,
have added both of them, then this would have been a Darshan solution, something like that. Right?
yeah, I think, but these parts he's not doing. He's directly getting the answer at last.
Okay. Yeah. Yeah.
That is the
Yeah.
logic.
Yeah, sorry.
So I don't know what he's using, but it's very, his solution will be very awesome.
Yeah.
Like, mhm.
Okay.
Then if we go to next, the next is our like music playlist. So it's like our music player contains n different songs and she wants to listen to L, which may not be, not necessarily be different during the trip. Okay. So we are supposed to create a playlist in which every song should be played at least once, and a song can be played again only if the other songs have been played. If your answer is this large, then just take the modulo of it. Okay. Uh, hmm. So what he's doing is there are three songs and she wants to listen to three songs. Okay. Yeah, and K is one. Like K is one means, let's say you have played song one, then you can't play song one again until you place one different song other than one. So first I played one, next I'll play two for her, and then I could have gone for one, but since she has to listen three different songs, that's why I'll take three over here and all the possible
I'm gonna
permutations.
need this for the whole day. Because Mama's using the monitor now, so in my computer.
Yeah. Yeah. So if you look here, K is 0. That means whatever song I have played, I can directly play that song without using any different song. So she wants to listen three songs. So first I played song one. I can play song two also, song one also, because K is 0. So these are all again the possible permutations of this. And here if you like three songs he has to listen. So I have two songs only with me. So first I played song one. Now I can't play song one because I need to play the other song because K is one, so I'll play two. But again, after that, I can play one. And other way, like you start from two, one, and two, you can do. And yeah, you have to take care. I mean, K has to be definitely less. That's obviously less than N. There are any queries in the example here?
So we have to find the number of ways the playlists can be arranged, right?
Yeah, given the above like restrictions. Yeah.
Possible playlists. Okay.
Hmm.
In the first one,
And we cannot have L as less than N, right?
L should be less than N. Then only you'll be able to play like sorry, L not K should be less than N.
Yeah,
L will
okay, I'm talking
yeah.
about N and L.
No L how no L will never be possible. L can be equal to N. L will never be
Right,
less than N.
right, right.
But if L is less than N, yeah, I see the note it says. L is only the, what you say, the length of the playlist, correct?
Then
So,
songs will be repeated.
yeah, it will be repeated, but should not be a problem though, right? But they have given a constraint, so it might not be.
K. But if
Yeah.
again, but let's say she wants to listen to three songs, and you have only two songs, and K is also K is one. Your repetition.
So,
No,
but
but
you
it
have
says that
number of
all the songs,
combinations, more number of combinations in that case, correct?
No.
but it says that all the songs have to be played. So I think they won't, the L won't be less than N.
Oh, okay. So that is the reason they are keeping it that condition. Okay, got it now.
If you have only two songs, then how will you play three songs? You will repeat only, no?
No, that is okay. But if the L is less, then we won't be able to play all the songs, right?
Yeah.
Yeah,
So
that makes
the
sense.
condition is we have to play at least once. Okay.
Perfect.
Good. Thanks for the clarification. Yeah. Well, this problem is super tough.
Yeah.
Yeah.
Yeah, very tough.
It's a very easy implementation, what is they are showing, but it's very hard to understand.
Understand.
Yeah, because what they are saying is, you assume only two conditions are there. Not assume, it's only two conditions will be there. Either you play a new song or you repeat a song. And then you add both the combinations. Right. But then I was seeing when I actually started printing value somewhere, but I found more number of combinations than my answer in some intermediate steps. So now I actually what
And
someone made a clarification about that N and N. That makes sense now. Yeah. Okay.
first, to get an intuition of DP, I don't know how
Yeah.
getting the intuition of DP. I mean, it's,
Yeah, same. I couldn't
yeah.
think of a brute force.
Yeah, brute force also thinking is like,
Is there a brute force?
I don't know. Yeah, there is a mathematical I've seen. Some
Yeah,
math there.
exclusion, inclusion, right.
Exclusion, gap
Okay.
inclusion, exclusion principle in PMC. But again,
Oh,
if
yeah.
who remembers, I mean, we have studied in class 12 and all.
Yeah. I
Yeah.
spent a long time on this, but actually I gave up. I
Yeah,
just
but to
went through
decide
that.
also that is inclusion, exclusion, that is also very tough.
Yeah,
Yeah.
you need to. So it's the same way our playlist also works, right? A song playlist, what we have. Re-
So there is one guy actually who was given a Java solution
yeah, share it.
using, well, actually, uh, I'll share it in the, what do you say, our Slack,
Yeah, yeah.
because I was trying to read it just before our session, but seems slightly he has given better description than the other guys. So maybe it might be slightly useful, but the code is very big. It's very huge.
No,
Yeah.
there are places like where you can see theoretical in one solution and code in other. Like somewhere code will be easier, explanation is bad. Somewhere explanation is awesome, code is worse. Yeah.
Python codes are the best.
Yeah, Python is better in this cases.
Yeah, like
So I can actually quickly share that link if you want, but
we can open. You can share the link.
okay, yeah, just go to the discussion forum.
Okay.
And then go down where you see all the 1, 2, 3, 4 those selection tabs.
Oh, business and okay, got. Yeah.
Go to the fourth one. Yeah, and at the very end you see that guy. Yeah.
I've shared in the group. I've shared in the chat.
The same
Yeah.
thing. This one.
Yeah, I don't know. I think that might be slightly different what he has given, but this one slightly better. He explains like the problem contains only 2 requirements: every song played once and the song played. Because if you play it once, then you actually tend to choose from the remaining ones, right? So therefore you can multiply by n minus whatever the n. Correct. And then so slightly better n minus k, right? In this case, n minus
K plus 1.
Yeah.
Sorry. K plus 1.
N minus j actually, because you are at that point, because you have consumed so many songs, that is what the value will be, right? So you just subtract that value and then multiply by that value will be okay. So slightly
out of box. Like,
could make out, because he's saying in the second requirement he shows like suppose if L is less than or equal to K, the answer would be n into n minus 1, n minus 2, something like that. Yeah, but I think Harshit shared something also, right? So that might be worth.
That is a different one. That is a more detailed one.
Let's open that.
But Harshit, do you want to explain this solution, what you are describing?
I can explain the first part. I mean, how do we get that count of n? But I didn't go through the code.
Yeah, whatever you understood, at least that will help.
Yeah, okay. So basically, if we try to find this thing, number of playlists containing at most n distinct songs. So for the first index, we have n choices. And going on for the next, we have n minus 1. And for the kth index, we have n minus k choices. So now for the next index, k plus month index, I can take the 0th song or the rest of the remaining songs. Those are n minus k plus 1. So if I add this n minus k plus 1, so this gives me n minus k choices. So this number would be This would be the number of songs for all those indices starting from k+1 till L. So this is what he has done.
So from k+1, it's repeating, right? The song which I have already
Right.
played, we are repeating from there.
Yeah. So the number. So for k+2th index, the number of options would be n minus k+2 plus the first two songs. That comes out to be n minus k.
Hmm.
It's
Can
really
we
tough
scroll down?
doing such formula. Yeah.
Yeah. Now, this is the first part. Now, what he has tried to do in the second part is, now this sequence where we say that uh, the number of music list that at most has n unique songs. Now this includes at most n-1 songs, at most n-2 songs till 1. So basically we have to subtract that thing because we need at most n unique songs only in our answer. So in the second part, he has tried to find count of n-1 and n-2 and further on.
That part
Subtracted
is
that.
slightly understandable than the previous one. Yeah. Okay.
Number
Yeah, but your actually explanation is slightly much better than the others. Yeah.
Yeah, so this count n-1 only. Now our aim is to find playlists containing at most n-1 distinct songs. So now what we do is we pick n-1 songs from n distinct songs. So that would be nc n-1. That is the first term, and we go on filling those blanks individually. So we get this thing c underscore n_n-1 till n-k+1 to the power l-k.
That is you're expanding or what? NCN-1.
So we are trying to find the number of playlists containing at most n-1 distinct songs. So what we do is we just pick up n-1 songs out of n songs, and then we try to fix them in those n-1 blanks. So for first one we have n-1 options, second one n-2, third one n-3.
Oh, that kind of arrangement, right?
Right.
So first you are out of n songs, you are selecting n-1 songs in the first step,
Yeah.
NC n-1, and now you are trying the ways to arrange these n-1 songs at n-1.
Yeah. With that condition being maintained that a song would repeat after the kth song only.
It's really tough to digest. Okay, let's go to the example. What this is.
So this is like a permutation or combination problem almost, right?
Yeah.
Would have a
Yeah.
mathematical formula also for that.
So 4 songs are there, no other song. 4C3.
I can't follow from this part after this, the lower part of the solution.
You mean to say how to calculate count n-1?
No, the duplicates part.
Oh, okay. Yeah. So there are
Also
some
reading this
duplicates.
before this call.
Yeah. Maybe more reading to be done. Yeah.
Yeah.
So, but the solution approach 1 is very easy to follow. I was trying to read the approach 2 and 3. They were not so good.
Yeah. This is a Twitter question.
Is it?
It's a Twitter question? Oh, okay.
Yeah.
Yeah, I'll just follow this one also. What is maybe read up for that, and if we can get some, something, we can actually have a small session after.
It's I don't know under which category to solve this problem. Like,
Yes, I was about to ask this. I mean, how do we categorize these problems?
Yes. But why don't we actually study some of us, and maybe next couple of days, if you find some time after our session, after a recording, we can actually discuss about this because it looks slightly interesting.
yeah, I mean a different category.
Yeah. more challenging. And if you're able to find something, we can share it.
Yeah, let's check it.
Yeah.
If tomorrow, day after tomorrow, we can do after.
Yeah.
Yeah, sure.
Yeah. Okay.
Voting also.
I was thinking about this brute force approach. Like, if we try to recursively call and maintain the songs which are already played and the songs which didn't play, and along with each song played, we maintain a time passed after playing that song. And each recursive call for the next song, we can select any of the song which has played and already qualified, like past time passed more than k, and also any of the song which is not played. Like that, if we recursively call, won't we get all the combinations at the end when we reach the time equal to n?
So you're trying to say it can be like done solved in a top-down approach, something like that, right?
Yeah. So it's similar, like if we try to find all the permutations of a like all the combinations of a number, like so we maintain all the songs which are played and which are not played, and along with each song played, we maintain a time passed after playing that song. And every time we play a new song, we can for each played song we can have multiple combinations. We can play the qualified played song, or which is not played for the first. We can play it for the first time and add it to the played song, and like that. We call recursively until we reach the time equals to n.
Very tough to say like that. I mean, until and unless.
Yeah. So does this solution work actually? Like,
I mean, I couldn't get like what you are saying. If you go with the diagram, that will be better. Otherwise.
Yeah, it might, because you'll have to do, because see, anyway, they have shown bottoms up approach. So whenever we see a bottoms up approach, surely there will have to be a top down approach. Then only they can derive this, correct? So I think what Dilip is saying might be there is something can be implemented. So, or maybe in the discussions we can find that.
I'll show you one discussion which I was going through.
I mean, what Dilip just mentioned, that looks like, I mean, though I'm not sure, but like unbound sort of knapsack with some condition. Because there are two choices, whether you can include the song or not include the song, right? You have to include the song, so there is a condition. You can include the song only if it was played that k.
After k different songs has been played.
Yeah.
That third condition makes it more, what to say, like adding more twist to the problem. Had it been like k equal to 0, then that's not a big deal. How will you take care of that? I mean, k songs has been played and then the song which I want.
No, but if you are able to find out, or maybe if you are saying if k equals 0 and it's very easy to implement, then we can actually build based on that, right? First, make a base condition of k equals 0, and then we add.
If I mean, we can start thinking like that. Let's assume k is not there at all.
Okay.
And now how can we build that?
Now it's like what you have to listen 3 songs, right? First you have to check whether your n is less than 3 or not. If it is equal to 3, then all the 3 songs must come, right?
So this is a simple combination problem.
Or you have to listen L song.
L song, that is mandatory. Like let's say song number 1, 2, 3 is there, and somebody is saying all the 3 songs has to be played, then there is no choice of leaving anyone. You have to take every one. So the possibility 1 plus 1 into 1 into 1, there is only one way, right? But if your number of songs is greater than the choice of the one who wants to listen, then in that case there is a possibility either you can include or can't include.
No, but if n equals 3, okay, and then
also,
n will also have to be 3, right? L will also at least have to be 3.
There is only one choice.
There is only one choice.
Yes.
No, 1, 2, 3.
Choice.
3 choice.
1, 2, 3, 2, 1, 3, 3, 2, 1. Like
that's the arrangement. Yeah, that's the arrangement. That's true. I mean, 3 factorial arrangement, 6 you'll
Okay.
have. But like only one way is there that you can't make other choice that of leaving it. You can start either from 2 1 3, or you can start 1 2 3 or 3 2 1, or again the permutation of it. 3 factorial permutation. But one, there is only one menu. Like you don't have any other option to leave this song, right? Until and unless the number of songs is greater than L.
So when you are saying k equals 0, it means that we are actually always picking up a new song, correct? That
You
what
can
comes to the
repeat on.
condition first.
Either
You
you
can
can pick the new song or you can repeat the same song.
Oh, in
exactly.
k equal to 0, you can repeat, yeah.
No, but you have to make sure that all the three songs should be covered. It shouldn't be like 1 1 2 3 is there. 1 to 1 can't be the answer.
Yeah. So
So if
your answer must include 1, 2, 3 at least once.
at least yeah, must. That is what the first condition is. After that you can repeat them, or you can, yeah, definitely you'll repeat only after that if the number of songs
L
less
is
than,
greater than N, yeah.
Yeah.
I mean, so many twists are there in this problem. Like,
True.
yeah, that makes it horrible. But here I didn't get much what this is saying on the surface level. I'm saying DP of ij is like, till now you have played j songs, and out of which I songs are different. This is what DP of ij means. That is the definition. So what your first formula here means, he's looking for, let's say you have played 6 songs, out of which 5 songs are different. So he'll look one, so if you want to play the previous song, just immediate previous song, if you want to play, so what you have to do, you have to play k different songs, then only j minus 1 song can be played. It's not
Yeah, that's
that's
correct, right? Yeah.
yeah. So but from where this I minus k I'm not getting.
So I is a unique number of songs what you are playing, correct?
Okay,
So you have come to that position. Okay. So when you want to play something which is already played, so what are you going to look from? You are going to look from
remaining
before I, right? So before
before
I, but you actually have to say because if you are on index 3, means I is 3 now. So you have already played 3 songs, correct? So,
okay,
but when you have to, at this position, if you have to add a already played song, then you cannot add all the 3 songs because the K factor is there. So if K is 1, so you'll be saying you can have only 2 songs which you can play, not all the 3. If K would have been 0, then you could have played all the 3, right? So that is what he's trying to say here.
can you explain once? I mean, I couldn't digest once more, like
Okay, so see, what is I? I is
different songs.
actually the number of unique songs. What is N actually, right? So you have some number of songs, which maybe you have number of songs like 4, okay? But you are on I index, which is 3. So you have already played 3 songs, right?
Okay.
So, but this condition says that you want to play a song which is already played, correct?
Okay.
So when you say that, so what is your choice? You can play any of the 3 songs, correct?
Yeah.
But the other constraint is K, right? So what K says, you cannot play all the 3 songs based on the number of K. So if my K number is 0, you can already play all the 3 songs. But if K becomes 1, so what you have to do, you cannot play at least 1 song, but you can play 2 songs, right? Because I will have a distance of 1K.
Different K, 2 different songs I have to play, then only that, yeah.
Right. So that is what he means by I minus 1, I minus K there.
Okay.
So because you have to look to the left side of that array, because you have already played songs, because you're going to pick up from that pool of songs which are already played, but you cannot play all of them based on the K constraint.
So if you are a third index, then from third K and K equal to 2, that means from third index 2 step back, you have to go and pick those songs, right?
If you are saying K equals 2, right?
And you are at third index, I equal to 3.
Yeah. So see, you don't worry about which song you want to pick. It's only the numbers what you are interested in, because it's only the number of ways, right? So in this case, you say you already have 3 songs which you already played, but your constraint says you cannot play 2 songs which are consecutive. So
Yeah.
obviously it will be only one song, right? So because you
Yeah.
cannot play two songs in the pool of three, so you can only maximum play one song.
One song. Yeah.
Yeah. So that is
Yeah.
what my understanding was by looking for the second requirement. So that made pretty clear. You know, when you look at the solution, it looks very clear, everything when he explains. But to come up with this, you know,
Like
so for that, actually, we have to go the way actually Dilip was saying,
exclusion.
right? Yeah, and Harshit also saying. So Harshit solution as well as Dilip's solution are top down. It might help us to understand how actually we have to, get to such problems, tough problems when we face some veterinary interview also. That is my thought process.
To form the intuition.
Right, right.
And
And these
it's
are not the advanced algorithms, okay? These are our normal algorithms still.
with complex logic. That's it.
Yeah,
Like,
it's only complex logic. But if you see the way he has implemented, it seems very easy. And the way they are explaining, it looks very easy.
intuitive. Yeah.
Yeah.
Second part is what telling that we can choose one of that is different from I minus one songs played. So in second part, that means J minus one songs you have played till now.
Yeah. So a second requirement is very easy, right? So because what he's trying to say,
From
you
first.
want to play a new song.
Okay.
Okay. So when you say new song, you cannot play any songs which are on the left side of the pool, which you have already played, correct?
Yeah. Yeah. Yeah.
So then what is doing is whatever the songs, the complete number of songs you have, which is n, you just subtract from that, whatever the songs you have played.
Already played.
Yeah.
Yeah. Yeah. It's not something.
Therefore, the requirement actually, when it comes to his explaining, it's very clear. But how he came to that, so that will be more easier if we go via the top-down approach. That is,
Yeah.
yeah. So if you are able to nail it down, then we will understand the whole flow.
Process.
Because bottom-up approach understanding is okay, but coming up bottom-up approach is very
It's a
difficult.
bit tough. Yeah.
So the best way, even if it's a longer process of understanding the top-down approach, yeah, I think it would be our better of our efforts, whatever we do. So we can actually at least have some solution and explain to in some cases when we come across such a problem.
Problem. Yeah. Nothing. And
Yeah,
code is simple. Nothing is there.
yeah, the code is very beautiful the way they have written.
Yeah.
No problem.
Yeah. Anyways, we'll check it.
Yeah, please, we'll try to do a session when we are done with our some session. We'll just spend 50-20 minutes on that. In this week only we'll try to make it. Okay.
Yeah. Yeah.
Can we solve this using a 1D array? Because I don't think J has any role to play.
Or you
Like
might
simply
use
run your loop from I equal to 1 till L.
No, but we are keeping track now till now. How many songs have we? I mean, how many songs?
See, the second condition plays an important role. Second, I think the first condition in this case. So if you don't have a 2D approach, it is fine, I would say, because you are not going to the upper array, upper rows. You always go to the next row. Yeah, it might be possible to optimize it.
Right.
Yeah. Yeah. So let's stop the recording.